MCV4U1, Chapter 6, Session 3. In this session, we are working on Section 6.1 from the textbook, an introduction to vectors. In physics, some quantities are completely known by just a number, which is called magnitude or size of the quantity. This type of quantities are called scalars. Temperature, mass, speed, length, and area are examples of scalars. Some other quantities require both a magnitude and a direction for a complete description. These are called vectors. Force, velocity, and accelerations are examples of vectors. A vector can be represented by a directed line segment. A directed line segment has a length, which is called the magnitude of the vector, and a direction indicated by an arrowhead. Let's have an example. By looking at this diagram, an airplane is traveling at the speed of 500 kilometers per hour. This description is useful, but it is incomplete for navigation and computational purposes. If we add the fact that the airplane is traveling in northeast direction, we now have a description of its velocity, because we have specified both its speed and direction. When we use a directed line to show a vector, A is called tail, B is called head. Vector AB is denoted by AB with an arrowhead, and length of AB, which is denoted by this notation, is magnitude of vector AB. A vector is a mathematical quantity having both magnitude and direction. Two vectors are opposite when they have the same magnitude but point in opposite direction. Therefore, vector BA is opposite of AB and vector AB is opposite of BA. If we use vector V to show AB, BA is denoted by negative V. And by definition, size of V and negative V are equal. Consider vector AB and CD. When line segment AB and CD are parallel and magnitude of AB, vector AB and magnitude vector CD are equal and they have the same direction, we say AB and CD are equal or equivalent. Vector AB, vector CD, and vector EF in this diagram are equal. If we look at this rhombus, vector AB and vector DC are equal. Vector E, AE, and vector EC, or vector DE and EB, are also equal. In this chapter, when we talk about vectors without considering reference or coordinate axis, we deal with geometric vectors, and when we have coordinate axis, we call it algebraic vectors. In summary, a vector is a mathematical quantity having both magnitude and direction. Scalar is a mathematical quantity having only magnitude. This notation, vector AB, represented a vector running from A to B. A is called tail, B is called head. This notation represents the magnitude of a vector, and it's always non-negative. When tail and head are the same, vector AA is called zero vector. Magnitude of zero vector is 0. Two vectors AB and BA are opposite if they are parallel and they have the same magnitude but opposite direction. Vector AB equals negative. Vector BA means AB and BA are opposite. Obviously, magnitude of AB and magnitude of BA are the same. Two vectors AB and CD are equal if they are parallel and they have the same magnitude and the same direction. Obviously, magnitude of AB and magnitude of CD are the same when two vectors are equal. Next session, we are working on question number 1, question number 4, question number 5, and question number 8 from page 279 and 280 of the textbook. Thanks for watching.